Hello guys, long time no see. This time I'm gonna introduce about the short channel effect. That the timing when the short channel effect occurs is that if we reduce the gate length, then the drain and source get more closer and closer, and at the moment that the depletion area between the substrate and source, and the other depletion area between the source and drain and substrate became overlapped each other, then the overlapping of the depletion area makes the some kind of channel. That this is because that the between the punch off that the fixed charge between the depletion area and the majority carrier of the substrate make the built-in potential, so that the carrier from the source can't overcome the potential wall. But if the depletion area becomes overlapped, then the majority carrier of the substrate can't block the source's majority carrier moves. So when the source and drain becomes closer sufficiently, then the carrier of the source can move through the depletion channel without the gate bias. So the interesting point of this situation is that if the depletion area is overlapped, then the depletion area's overlap is pretty far from the gate, because if the because it acts like it wants to act without the gate bias. So this situation's problem is that we can't control the MOSFET through the gate bias, and there is a few solutions of this situation. First thing is that the increasing the doping concentration of the substrate, but it is quite suck because the increasing the concentration of the substrate is makes lower mobility. So the other solution is that the slicing the bottom of the substrate, that which, when I said few times before, the depletion channel of the punch off is formed at the far from the gate. So if we cut the physical distance of the substrate, then depletion channel can't be made. But this solution's disadvantage is that the heat between the substrate, the heat in the substrate can't easily go through the outside. So the device getting more hotter and hotter. The last solution is that using the different material as substrate, which can make the quantum well of the substrate band diagram, but this is pretty expensive and there is a hazardous of the tunneling. So the three solutions have each disadvantage. Thank you.